Hi friends, welcome to the DevOps testing tutorial. Before that, if you haven't watched the previous tutorial of 5 test management tools, please click on the link above or in the link in description. We might be aware or may have worked with the methodologies like Agile, DevOps, continuous delivery and more. DevOps has become an increasingly common approach to software delivery that development and operations teams use to build, test, deploy, and monitor applications with speed, quality, and control. So let's take a detailed look on the DevOps, what, why and how aspects, some DevOps tools and how it differs from Agile. So, first thing first. What is DevOps? The word DevOps is a mashup of development and operations. It represents a set of ideas and practices. A compound of development dev and operations ops. DevOps is the union of people, processes and technology to continually provide value to customers. DevOps describes approaches to speeding up the processes by which an idea goes from development to deployment in a production environment quickly. Idea can include a new software feature, a request for enhancement, or a bug fix. So DevOps aims to shorten the system's development life cycle and provide continuous delivery with high software quality. DevOps is complementary with Agile software development. Several DevOps aspects came from Agile methodology. Of course, this means more frequent changes to code and more dynamic infrastructure usage. Traditional management strategies can't keep up with this kind of demand. The first question comes in our mind: why do we need DevOps when we already have other methodologies? Let's see the 6 reasons why do we need DevOps. Well, the first reason, with DevOps, you move at high velocity so you can innovate for customers faster, adapt to changing markets better, and grow more efficient at driving business results. The DevOps model enables your developers and operations teams to achieve these results. For example, microservices and continuous delivery let teams take ownership of services and then release updates to them quicker. Secondly, with DevOps, you increase the frequency and pace of releases so you can innovate and improve your product faster. The quicker you release new features and fix bugs, the faster you can respond to your customers' needs and build competitive advantage. For example, continuous integration and continuous delivery are practices that automate the software release process, from build to deploy. Thirdly, you can operate and manage infrastructure and development processes at scale. Automation and consistency help you manage complex and changing systems efficiently and with reduced risk. For example, infrastructure as code helps you manage your development, testing, and production environments in a repeatable and more efficient manner. Then next, since DevOps takes 2 disciplines, development and operations, which were traditionally siloed into one discipline, it inculcates a culture that is characterized by increased communication and collaboration. This reduces inefficiencies and saves time. Fifth reason, reduced time to market, reduced risk, greater product quality and team collaboration bring every kind of efficiency including cost efficiency. Lastly, with DevOps, you ensure the quality of application updates and infrastructure changes and therefore you can reliably deliver at a more rapid pace which results into a positive experience for end users. For instance, you can use practices like continuous integration and continuous delivery to test that each change is functional and safe. Development and operations both play essential roles in order to deliver applications. The deployment comprises analyzing the requirements, designing, developing, and testing of the software components or frameworks. The operation consists of the administrative processes, services, and support for the software. When both the development and operations are combined with collaborating, then the DevOps architecture is the solution to fix the gap between deployment and operation terms, therefore, delivery can be faster. Let's see the DevOps components in details next. The DevOps reference architecture shown in figure proposes the following 4 sets of adoption paths or components. 1. Plan. 2. Develop and test. 3. Deploy. 4. Operate. First, in plan component, DevOps use Agile methodology to plan the development. With the operations and development team in sync, DevOps helps to reconcile various competing perspectives, helping teams collaboratively establish business goals and continuously change them based on customer feedback, which improves both agility and business outcomes. Second component, development and testing, involves 2 practices, collaborative development and continuous testing. Let's talk about these 2 practices in brief. Software delivery usually involve large numbers of cross-functional teams, including business owners, business analysts, architects, developers, operations teams, security specialists, suppliers, and partners. Collaborative development enables these practitioners to work together by providing a common set of practices and a common platform to create and deliver software. They work with the help of a capability of collaborative development called continuous integration. Whereas the second practice, continuous testing, means testing earlier and continuously across the life cycle, which results in reduced costs, shortened testing cycles, and achieved continuous feedback on quality. This process is also known as shift-left testing, which stresses integrating development and testing activities to ensure quality is built in as early in the life cycle as possible. This practice is facilitated by adopting capabilities like automated testing and service virtualization. Third component, the deploy component, is where most of the root capabilities of DevOps are originated. Continuous release and deployment take the concept of continuous integration to the next step. The goal of continuous release and deployment is to release new features to customers and users as soon as possible. Fourth component, operate, includes two practices that allow businesses to monitor how released applications are performing in production and to receive feedback from customers. First practice is continuous monitoring, which provides data and metrics to the team and stakeholders about applications at different stages of the delivery cycle. This metrics allow stakeholders to take an action by changing the features being delivered. Second practice in the operate component is continuous customer feedback and optimization, which use the data about how customers use the application and feedback that those customers provide upon using the application. There are three technology capabilities in DevOps which we would discuss: infrastructure as code, delivery pipeline, and deployment automation and release management. First technology capability is infrastructure as code, which is a core capability of DevOps that allows organizations to manage the scale and the speed with which environments need to be provisioned and configured to enable continuous delivery. Three kinds of automation tools are available for managing infrastructure as code: application or middleware-centric tools, then environment and deployment tools, and also some generic tools. Second technology capability is delivery pipeline. A delivery pipeline consists of the stages an application goes through from development through to production. A typical delivery pipeline has the stages described in the following sections: development environment, build stage, package repository, test environment. Third technology capability in DevOps is deployment automation and release management. Deployment automation tools are the core tools in the DevOps space. Such tools perform orchestrated deployments. They can also manage the configurations of the environments of all the stages. Whereas release management tools allow organizations to plan and execute releases, provide a single collaboration portal for all stakeholders in a release, and provide traceability for a release and its components across all stages of the build and delivery. Let's take a look on the DevOps life cycle. First is continuous improvement. An organization should have built-in processes that identify areas for improvement as the organization matures and learns from the processes it has adopted. There are several methods for this, like observations and lessons learned, self-assessment, and determine own process improvement paths. Regardless of the method used, the goal is to enable continuous improvement. Second, release planning. Release planning is a critical business function, driven by business needs to offer capabilities to customers and the timelines of these needs. Therefore, businesses require well-defined release planning. Leveraging lean and agile practices also results in smaller, more frequent releases with enhanced focus on quality. Third, continuous integration. Continuous integration is a software development practice where developers regularly merge their code changes into a central repository, after which automated builds and tests are run. The key goals of continuous integration are to find and address bugs quicker, improve software quality, and reduce the time it takes to validate and release new software updates. Fourth, continuous delivery. It's again a software development practice where code changes are automatically built, tested, and prepared for a release to production. It expands upon continuous integration by deploying all code changes to a testing environment or a production environment after the build stage. When continuous delivery is implemented properly, developers will always have a deployment-ready build artifact that has passed through a standardized test process. Fifth, continuous testing. We need to adopt processes in three areas to enable continuous testing: test environment provisioning and configuration. Test data management. Test integration, function, performance, and security. And sixth, continuous monitoring and feedback. Continuous monitoring means having full, real-time visibility into the performance and health of the entire application stack, from the underlying infrastructure running the application to higher-level software components. High-performing DevOps teams ensure that they set actionable, meaningful alerts and collect rich telemetry so they can draw insights from vast amounts of data. These insights help the team mitigate issues in real time and see how to improve the application in future development cycles. So we here and may be using Agile and DevOps interchangeably. Let's see how Agile and DevOps differ from each other. First of all, in Agile, we bridge the gap between the development team and the end user. Whereas in DevOps, we bring people, process and technology together to deliver continuous value. Then focus of Agile is adaptability and keeping pace with customer needs and expectations. Whereas DevOps focus on maximizing efficiency, identifying programmable processes and increasing automation. Also, Agile scope is specific to the development team and completing the project. Whereas DevOps scope represents the intersections of development, operations and quality assurance. In Agile, feedback is given by the customer, whereas in DevOps, feedback comes from the internal team. Also in Agile, we focus on speed, whereas DevOps also focus on automation. In terms of documentation, Agile believes in less documentation, whereas DevOps takes documentation seriously, in order to fully understand a software release. The famous manifestations of Agile are Scrum, Kanban, extreme programming, where of DevOps are continuous integration, continuous delivery, continuous deployment. Then we have tools of Agile including Jira, Bugzilla, Kanban, whereas in DevOps, we use more for automation or key and CD tools that includes Puppet, Chef, TeamCity, OpenStack, AWS. So, what are the main DevOps tools? Let's take a look on the tools category-wise. First category is planning tools. These tools include Azure DevOps Boards and Jira. Azure Board is nothing but work management tool using that teams can plan their works, track progress across the teams, manage backlogs and sprint planning, team dashboards, query and custom reports. Whereas Jira is a very famous Agile project management tool for software planning, that support all Agile methodology like Scrum, Kanban. Second category is for code management, which includes Git and TFVC. Git is a version control system, allows us to manage all versions of our code or files, whereas Team Foundation version control is a centralized version control system. Here team member has only one file on the machine and historical data is maintained on the main server. Third category is tools for testing automation, includes Selenium and JMeter. Selenium is one of the highly recommended automated software testing tool for testing web applications. It automates browser, enabling tester to manage test scripts received for specific testing purposes. Apache JMeter is Java-based open-source software for performance testing. Then comes the main category of DevOps tools, which is tools for build, continuous integration, continuous deployment and monitor. It has a wide variety of tools, some of them are Ant, Maven, Jenkins, Bamboo, TeamCity, Docker, Kubernetes, Splunk, Puppet, Chef, Ansible, Shippable and Nagios. These tools are so popular and commonly used in DevOps, we would discuss these tools in some other video. Hope we don't land up in such situation while working in DevOps. Hope you have gained some useful insights from this DevOps tutorial. DevOps is all about practices, principles and developing a collaborative environment that enhances software delivery and improves business value. The concept essentially remains the same. Automation and more automation is the core of a successful DevOps cycle. But, we should also decide as to how much automation is required. Please like, share, subscribe and comment so that we are motivated enough to come up with such knowledge sharing videos. Thanks for watching, see you in the next one.